Right, we are actually here focusing on trigonometry, and we are given the following question. If cosine of 26 degrees equals m, find in terms of m without using a calculator 2 sine squared of 77 degrees in part A. And in part B, we have the sine of 20 degrees. We present the solutions to both parts, A and B, in a step-by-step fashion as follows. Right. First things first, we are actually looking at part A, but in part A, we have been told that if we have the cosine of 26 degrees and if this equals m. Right. So we know very well that if this is the case, these are trigonometric ratios, and we're going to use here SOHCAHTOA. Right. We're going to use here SOHCAHTOA. And SOHCAHTOA is very clear that the cosine will actually therefore be adjacent of hypotenuse. And if this angle is 26 degrees, right, and this one is 64 degrees, like this. So if you have adjacent of hypotenuse, you have adjacent over hypotenuse, like so. Moreover, we are able to analyze this and see that we are left with one side of this triangle, and we're going to use x squared plus y squared, which is r squared, and this is a credit to what we call Pythagoras. Right, Pythagoras result. But Pythagoras, we have the following. What is our x? Okay, so clearly this is our x, and this is our r, and this stands our y. So which means our x will be actually obviously m squared. Y is what we're looking for, and r is actually 1, so that we solve for y, and y becomes plus or minus the square root of 1 minus m squared. And obviously, in view of the fact that we're dealing with an acute angle in the first quadrant, 26 degrees being an angle in the first quadrant, so hence y is only the square root here of 1 minus m squared. Right, so here this becomes the square root of 1 minus m squared. Like so. Okay, now we proceed to look at the fact that we need to just deal with 2 sine squared of 77 degrees. 2 sine squared of 77 degrees. Thus, still looking at part A. Right, still looking at part A. Thus, to the trigonometric sine squared of 77 degrees. This is exactly equal to 2 the sine squared of 90 degrees minus 13 degrees. Okay, because 90 degrees minus 13 degrees is 77 degrees. Upon further examination, 90 degrees minus 13 degrees is an angle in the first quadrant where all trigonometric ratios are positive. So we're going to have a positive result, but there's a cofunction change here. And the cofunction of the sine is the cosine squared of 13 degrees. Moreover, we then realize that here, if we put here minus 1 plus 1, right, so that 2 cosine squared of 13 degrees minus 1 is actually the same as cosine of 2 times 13 degrees plus 1. Right, so And this is exactly cosine of 26 degrees because 2 times 13 is 26 degrees. And therefore, what is the cosine of 26 degrees? Okay, it is exactly m according to the given question. Proceeding with part A, we're able to see that hence the 2 sine squared of 77 degrees is actually m plus 1. M plus 1. And we have solved part A in detail. And we proceed right now to focus on the second part of this question. Here we use the double angle formula in trigonometry, that if you have cosine of double x twice x is the same as 2 cosine squared of x minus 1. And this is the double angle formula for the cosine function. And we are excited. Okay. And that takes us to the end of the first part of the question. And we focus now on the second part of the question. The second part of the question now is to focus on the sine of 20 degrees. What is the sine of 20 degrees? Right, so the sine of 20 degrees can as well be obtained here, and we proceed to attempt part B. Right, so part B is straightforward. So if you have the trigonometric sine of 20 degrees, we can write these as the sine of 52 degrees minus 32 degrees. And this is exactly the same as the sine of 52 degrees cosine 32 degrees minus cosine 52 degrees, the sine of 32 degrees. Okay, so what is this? This is exactly the sine of 2 times 26 degrees. Okay. And then here we maintain and keep the cosine of 32 degrees minus the cosine of 2 times 26 degrees multiplied by the sine of 32 degrees. Okay. Right. So what is the meaning of all these here? So from these, we have therefore that the sine of 20 degrees. Okay, now here we use the double angle formula 2. The sine of 2 times 26 is 2 the sine of 26 degrees cosine 26 degrees. Cosine 32 degrees. Minus. So if you look at this here, what do we have? Right, the cosine of 2 times 26 is the same as 2 cosine squared of 26 degrees minus 1 times the sine of 32 degrees, like so. And what is the meaning of all this here? Okay, let us reason together and prepare ourselves to solve this. So the sine of 26 can be obtained. And we have, therefore, the sine of 20 degrees, which equals, what is the sine of 26 degrees? The sine of 26 degrees is actually the opposite of the hypotenuse. So the sine of 26 degrees, therefore, is the square root of 1 minus m squared over 1, which is 2 into the square root of 1 minus m squared. Right, the cosine of 26 degrees was given as m. That leaves us with just a cosine of 32 degrees here. Minus into 2, the cosine of 26 is m, so that is m squared minus 1, the sine of 32 degrees. Like so. It remains to just find the cosine of 32 and the sine of 32 degrees. And we find those as follows. Right. Cosine of 64 degrees equals. Right, so the cosine of 64 degrees can be written as a double angle 2 times 32 degrees. And this is the same as 2 cosine squared of 32 degrees minus 1. So that this has transformed for us cosine of 64 degrees, which is 2 cosine squared of 32 degrees minus 1. And what is the cosine of 64 degrees? What is the cosine of 64 degrees? Okay, cosine of 64 degrees is adjacent over hypotenuse, adjacent of hypotenuse using the SOHCAHTOA, and therefore that gives us the square root of 1 minus m squared all over 1. So this becomes the square root of 1 minus m squared, which is equal to 2 cosine squared of 32 degrees minus 1. So you have 32 degrees. So which is 1 plus the square root 1 minus m squared. So that you have 32 degrees. You divide by 2 and you take the square root. Right, so if you divide by 2 and you take the square root, 32 degrees is actually an acute angle. And that means if you have the cosine of 32 degrees here, so this becomes exactly the same as the following, right? So it becomes the same as 1 plus 1 minus m squared all over 2 square root. Like this. Okay, so only plus because we are dealing with cosine of 32 degrees, and 32 degrees is in the first quadrant where all the trigonometric ratios are positive. Next. We find now the we also note that, but cosine 64 degrees is the same. 64 is 2 times 32 degrees. Using double angle expansion, we have 1 minus 2 sine squared of 32 degrees. And now cosine of 64, we've already seen, is 1 minus the square root of 1 minus m squared equals 1 minus 2 sine squared of 32 degrees. Sine squared of 32 degrees. Right, we need to manipulate this and make the sine of 32 degrees the subject of this equation. And we have 32 degrees, which is 1 minus the square root here of 1 minus m squared. Right, upon further examination, we proceed to find the sine of 32 degrees. And we divide by 2 and apply the big square root. Right, so if we divide by 2 and we apply the giant square root, we obtain the following. So this is exactly 1 minus the square root of 1 minus m squared divided by 2. And we have this. Okay. Okay, what is the meaning of everything that we've got? Right, so hence, right, hence, the sine of 20 degrees. We have already seen from this particular part of our working, right? So you have 2 the square root of 1 minus m squared m cosine 32. 2 the square root 1 minus m squared m cosine 32 degrees. Okay. Cosine of 32 degrees. Right, minus. And we have seen that we actually got 2m squared minus 1 times the sine of 32 degrees. So that we obtain the sine of 20 degrees, which equals, so you have m here, and this is exactly 2m the square root of 1 minus m squared. And therefore the cosine of 32 degrees. Cosine of 32 degrees is the same as the square root of 1 plus the square root of 1 minus m squared over 2. So we're good. So this here, 1 plus the square root 1 minus m squared all over 2 minus 2m squared minus 1, then the sine of 32 degrees is the same as the square root. Right, the square root of 1 minus the square root of 1 minus m squared over 2 like this. Right, and this here is exactly the answer as required. So we have solved this in detail, and we have analyzed the full question. And thanks everybody for your time and attention, and very, very goodbye to you.